This video presents an overview of the smart charging infrastructure for power mobility devices. First, let us look at the outline of this video presentation. This video covers several key points. It starts by showcasing the proposed charger, followed by introducing the Data Acquisition and Sensing System, DAS. Then it shows the functionalities of the WAP mobile app and how each of its pages works. Finally, a charging session is demonstrated, and the video concludes by presenting the website designed for power wheelchair charging stations. First, let us show the charger and explain its features. This charger station is intended for public charging of power wheelchairs and scooters. It is designed to be mobile, compact, convenient, and efficient. When on, the charger will display the charging status in the middle of the 7-inch display. Its name identifier and location are shown at the top left of the screen, and the current time is at the top right. To turn on the charger, plug the power cable into the AC wall outlet. The cable from the charger to the wheelchair is a male 3-pin XLR plug, compatible with a female 3-pin XLR receptacle. There are also USB-A and C outlets to allow charging cell phones and tablets. The charger is mounted on a mobile pole using a commonly used Visa mount stand, which allows an adjustable mounting angle for maximum accessibility. Let us briefly present the charger specifications. The charger features a two-stage structure comprising boost, PFC, and LLC power converters, allowing programmable power output ranging from 50 to 330 watts for all 24-volt lead-acid battery packs. It can operate connected to the single-phase 120-volt grid used in the USA or the 220-volt single-phase grid used in Europe, Asia, and elsewhere. It includes various protection features listed on the screen. The charger has undergone rigorous testing to verify that it meets power factor, total harmonic distortion, and conducted EMI safety standards. Now, let's move on to the Data Acquisition and Sensing System, or DAS. The DAS is a sensing and computational unit that can be optionally installed on the wheelchair. It can be turned on and off using the switch on the left. The parameters measured by the DAS are the wheelchair acceleration, battery and ambient temperatures, humidity, air pressure, battery voltage and current, and GPS data. All data are recorded and can be uploaded to a dedicated database to customize and improve the AI-based battery energy consumption estimator. The DAS also uses measured battery values to calculate the battery level accurately in real time and track the number of charging cycles performed on the battery pair. The DAS is powered from a separate battery for reliable operation and can operate for hours even after the main batteries are discharged. The DAS fits nicely inside the battery compartment. Now let's move on to the wheelchair charging app, WAP. WAP is a mobile application designed to assist wheelchair users by locating accessible public charging stations, planning optimal routes, showing the battery level in real time, and initiating and monitoring the charging process. After starting the app, users can sign in using their existing email and WAP password or sign up using the link at the bottom of the entry page. Once signed in, the app will keep the user's session active until the user logs out using the Logout button on the user profile page. Let's sign up for the first time. Users provide an email and password with the option to display the password using the eye icon on the right for enhanced accessibility. In this video, the playback speed is increased for demonstration purposes. The user profile page allows the user to enter personal and wheelchair information. Mandatory information includes first and last names, maximum battery current, voltage, and number of charging cycles. The maximum battery voltage, current, and number of charging cycles can be auto-populated if the wheelchair model is presented in the database. Otherwise, the user should use the battery datasheet to identify these parameters before entering them. The user can fill out the optional fields, such as wheelchair name and DAS serial number. If the DAS unit is installed in the wheelchair, its serial number can be found on the back of the unit. For better accessibility, the font size can be adjusted to be small, medium, or large. The user can save the changes by pressing the Update Profile button. The home page allows users to connect to the wheelchair, display the battery level and charging cycle counter, and upload the data recorded by the DAS to the cloud database. To switch between the Home, Route, Charging, and About pages, one can use the navigation bar at the bottom of the home page. After pressing the Connect to Wheelchair button, the app scans for available DAS units. The app only connects to the DAS unit whose serial number is entered on the user profile page. After connecting to the DAS, the real-time battery level is shown on top. The number of battery charging cycles, which indicates the battery's age, is shown underneath the battery level. When a new pair of batteries is installed, the user should reset the battery charging cycle counter by pressing the Reset Battery Cycles button. If a DAS is installed, data can be uploaded in the following manner. This diagram illustrates the process of uploading data collected by the DAS. By pressing the Upload Data button, the app sends a request to the DAS to upload the collected data to the cloud. The uploaded data can then be used to customize the wheelchair energy consumption estimation. To preserve the user's privacy, data is only uploaded if the user requests and confirms the request. Finally, after the data is uploaded, the Last Upload field is updated to show the current date. The Route Planner is designed based on the Google Maps API, inheriting most of Google Maps' functionalities. On the map, 5 charging stations are shown. 2 are green, indicating they are available, and 3 are yellow, indicating they are currently in use. Information about the selected charger is shown at the bottom of the screen, including working hours, charger status, accessibility, transportation modes, and the Directions button. The user can choose from 3 transportation modes: wheelchair, car, or public transportation. After choosing one of the modes, the user can press the Directions button to display the route to the selected charger from the user's current location. Once the Directions button is pressed, the information about the selected route, the wheelchair weight, and the current road and weather conditions are sent to the cloud-based artificial neural network algorithm that estimates the distance, traveled time, and required energy to complete the trip. After a couple of seconds, the calculated values are displayed on the screen. If the DAS system is installed, the estimated values are customized based on the user's and wheelchair's data, offering enhanced prediction accuracy. Otherwise, a generic average wheelchair and user are considered for calculations. Let us see how the route information changes when the user selects a bus or car as a transportation mode. Here, the playback speed is increased for demonstration purposes. Now let's move on to the WAP About page. The About page contains the app information and instructions, as well as the team that developed the app and their contact information. Now let's move on to the demonstration of the charging process. In this video, the playback speed is increased for demonstration purposes. Once in the proximity of a charger, the user may navigate to the charging page on the WAP. If no chargers are shown, They can be found by pressing the Search for Chargers button. After connecting to the charger by selecting its name, a message pops up requesting the user to plug the charger cable into the wheelchair. After the cable connection is established, the charging process begins. The charging time, current charging power, and total delivered energy are shown on the bottom of the charger screen. In this example, at the beginning of the charging process, the battery level is 52.3%. As time passes, the battery level increases and reaches 52.8%. The charging is then terminated manually by disconnecting the wheelchair cable. Alternatively, when the batteries are fully charged, the charger will automatically terminate the charging and ask the user to disconnect the power cable. Now let's move on to the web application. The web application is an integral part of the wheelchair charging infrastructure. It allows users to locate and navigate to chargers without using the WAP mobile app. Moreover, it allows charger owners to request new chargers be added to the map or to modify information about or delete existing chargers. At the top of the page is a navigation bar. Users can create an account or sign in to their existing accounts. Let us create a new account for demonstration. The playback speed is increased for demonstration purposes. After signing up, the user is directed to the map page. To use the web application map, the user should allow the application to know their location. The map page is designed based on the Google Maps API, inheriting most of Google Maps functionalities. There are 3 transportation modes: car, bus or train, and wheelchair modes. After selecting the charger, its name, availability, location, and working hours are shown on the screen. You can use the Directions button to display routes between the selected charger and your current location or another location. As mentioned before, the web application allows charger owners to request new chargers be added to the map. Let us see how this works. Once on the My Charger page, you can request adding a new charger by pressing the plus button. The charger and owner's information is entered on this page. After completing the form and pressing the Request for Charger button at the bottom of the page, the information about the requested charger is shown on the My Charger page with the status Pending. Charger owners have the option to update or delete their requests as well. If the admin approves the request, the status will change to Approved and the charger will appear on the map. This concludes our overview of the smart charging infrastructure for power mobility devices. We would like to thank everyone who contributed to the charger development.